Welcome back to the second part of section 423. Today we're going to be talking about solving absolute value equations. Now keep in mind, when we're talking about the absolute value of a number is always positive. So the absolute value of 3 is 3, and the absolute value of negative 3 is 3. We're talking about the distance away from 0. So when we take the absolute value of a number, we're always going to get a positive number in return because distance is always a positive number. So now, if we're looking at solving these, for number 8, for example, the absolute value of a number equals 5. So think, the absolute value of a number equals 5. The absolute value of 5 equals 5, but also the absolute value of negative 5 equals 5. So what's in the absolute value bars? That could be a 5 or a negative 5. So we have to take into account both scenarios. So x minus 3 could equal positive 5, or x minus 3, what's in the absolute value bars, could equal a negative 5. We need to write two equations to get rid of our absolute value bars. So now we solve, we add 3 to both sides. X equals 8. Add 3 to both sides. X equals negative 2. There's our two solutions. And we can check to show you that it works. The absolute value of 8 minus 3 equals 5. So the absolute value of 5 equals 5. That's a valid solution. And even the negative 2 minus 3. So the absolute value of negative 2 minus 3, the absolute value of negative 5 equals 5. 5 equals 5. They both work. We had to find both solutions. For number 9, remember, what's in the absolute value bars? That could be a positive 45 or a negative 45. So we have to write both situations. 5x minus 10 equals 45. 5x minus 10 equals negative 45. Add 10 to both sides. 5x equals 55. Divide both sides by 5. X equals 11. Add 10 to both sides. 5x equals negative 35. Divide both sides by 5. X equals negative 7. There's our two solutions. So like I said, you could substitute back in and check your answer. Now, for number 10, the absolute value of x plus 5 equals negative 10. Now, when I think about this, the absolute value of 10 equals 10. Even if I had a negative 10 in there, absolute value of negative 10 also equals 10. Because we have the absolute value equal a negative number, that can't happen. There's no solution. You can't take the absolute value of a number and get a negative. The absolute value of a number will never equal 0. Looking at problem number 11, the absolute value of a number equals 8, so we could have an 8 or a negative 8 there. So 3x minus 3 equals 8. 3x minus 3 equals negative 8. Add 3 to both sides. 3x equals 11. Divide both sides by 3. X equals 11 thirds. Add 3 to both sides. 3x equals negative 5. Divide both sides by 3. X equals negative 5 thirds. There's our two solutions. Now they're getting a little bit more complicated, a little bit more going on. Before we do anything with problem number 12, we have to isolate the absolute value bars. Always make sure those absolute value bars are isolated. So we're going to subtract 6 from both sides. The absolute value of 2/3 x plus 2 equals 0. Now, 0 doesn't have a sign. 0 is 0. It's not positive. It's not negative. So we only have to write one equation here. 2/3 x plus 2 equals 0. Subtract 2 from both sides. 2/3 x equals -2. And then we can multiply both sides by 3/2. So when we do that, we get x equals, the 2's cancel, they become 1. So we have -1 times 3, so -3 is our only solution for x. Number 4, once again, isolate. So we have to add 5 to both sides first. 4 times the absolute value of 2x minus 3 equals 12. Divide both sides by 4. 2x plus 3 equals 3. I'm sorry, absolute value of that. So then remember, the absolute value could be a 3 or a -3 inside. So our two equations, 2x plus 3 equals 3. 2x plus 3 equals -3. Subtract 3 from both sides, 2x equals 0. Divide both sides by 2, x equals 0. Subtract 3 from both sides, 2x equals -6. Divide both sides by 2, x equals -3. And there's our two solutions. Okay, moving forward. Problem number 14 and 15. They're different than the others because they have x on the outside. Now, with that, we do the same exact thing. We still set two equations. 2x plus 12 equals 4x. 2x plus 12 equals -4x. So they're very similar to start off with. Subtract 2x from both sides. 12 equals 2x, divide by 2. X equals 6. Subtract 2x from both sides. 12 equals -6x. Divide both sides by -6. X equals -2. When you see x on the outside of the absolute value bars, you must check your solutions. You have to check for these. Absolute value of 2 times 6 plus 12 equals 4 times 6. Absolute value of 12 plus 12 equals 24. Absolute value of 24 equals 24. 24 equals 24. That's a valid solution. Absolute value of 2 times -2 plus 12 equals 4 times -2. Absolute value of -4 plus 12 equals -8. Absolute value of 8 equals -8. The absolute value of 8 is 8 equals -8. 8 does not equal -8. That's not a valid solution. So the -2 is extraneous. So we cross it out and we just keep the x equals 6. So we have to check for extraneous. Very similar problem for number 15. 4x plus 10 equals 6x. 4x plus 10 equals -6x. We do the same thing. Subtract 4x from both sides. 10 equals 2x. Divide both sides by 2. X equals 5. Subtract 4x from both sides. 10 equals -10x. Divide both sides by -10. X equals -1. And don't forget to check for extraneous. When we check for extraneous, we always go back in the original. Absolute value of 4 times 5 plus 10 equals 6 times 5. 4 times 5 is 20 plus 10 equals 30. Absolute value of 30 equals 30. So we get 30 equals 30. That's a valid solution. And then 4 times -1 plus 10 equals 6 times -1. So it's the absolute value of -4 plus 10 equals negative 6. So the absolute value of 6 equals negative 6. 6 equals negative 6 is a false statement. X equals negative 1 is extraneous, and you get x equals 5. Be careful with that. Don't always just throw out the negative. There are cases where the negative value is the actual answer. So don't just throw them out. Always check for extraneous and let the math do the work for you. And that is solving absolute value equations. The key there, solving absolute value equations, writing two equations to get rid of the absolute value bars. Thank you, and I'll see you in the next video.